Hi, how's it going, everyone? Welcome back to the channel. If you're new here, thank you for tuning in, and be sure to check out some of my other videos. And if you find the video helpful, be sure to leave a like or a comment. In my last video, I went over setting up a free mail server using Mailhog, and we deployed that on Amazon ECS through the AWS console. In today's video, we'll do the same, but we'll provision all the AWS resources like we did in the previous video using code instead of doing it through the AWS console. To do that, we'll be using Terraform, which is a DevOps tool used to define infrastructure as code. In my VS Code, I've got the AWS Toolkit extension, which will give me a preview of my AWS services as I provision them. So instead of constantly signing into my AWS console, I can simply preview everything in my VS Code. So we'll provision an ECS cluster, define our task definition, and launch a service running the Mailhog instance. To get started, I'll create 3 files in my project, the main.tf file, where I'll define my provider. In this case, the provider will be AWS, but you could also define other cloud providers such as Azure or GCP. In the network.tf file, I'll define the security group inbound and outbound rules. And lastly, in the ECS.tf file, I'll provision the ECS cluster and define the task definition and the service. So let's go ahead and define our provider in the main.tf file. Once we've got that, we'll then specify the region and the AWS account where our AWS resources should be provisioned. I'll use the US East 1 region. I've already configured my AWS account locally. If I go in my terminal, I can list all my AWS accounts that I have configured using the AWS CLI. If you need to configure your account, first install the AWS CLI and then run the following command to configure a new account and provide your AWS credentials. Next, we'll define our security group in the network.tf file, and we can always refer to the Terraform provider docs for details of the service we're defining. So for our security group, as you can see, we'll need to provide all these details for our resource, which includes the inbound rules and outbound rules, just like we did in the previous video. So let's go ahead and do that. We'll name the security group Mailhog SG and give it a description. We also need to specify the VPC ID for the security group. So we'll launch our security group in the default AWS VPC, which we can preview using the AWS Toolkit or through the AWS console. You could also provision a new VPC and deploy the mail server there instead. Instead of typing in the VPC ID, we'll retrieve the ID using a data source, which will allow us to fetch the details of the existing resource. Next, let's define our inbound rules. If you remember from the previous video, we had to define 2 inbound rules, one for the port 8025 and another for port 1025, and allow traffic from anywhere. Lastly, we'll add an outbound rule allowing all outbound traffic to any destination. And then for the VPC ID, let's define a VPC data source and get the default VPC ID and pass that in our security group. Now let's go ahead and define our ECS cluster, task definition, and service. We'll start with the cluster. I'll name it Mailhog cluster and give it a tag of the same name. Currently, I don't have any clusters, so let's go ahead and provision the cluster. For this, you'll need the Terraform CLI installed. We'll first run the Terraform init command to initialize our Terraform configuration. Next, I'll run the Terraform format command to format my code and then validate my code to ensure that everything is correct. Lastly, we can preview our changes using the Terraform plan command before applying, and then apply our code using the Terraform apply command to provision the ECS cluster and launch the security group. I'll give it a moment to apply my code. And when I head into the ECS console, I now have my ECS cluster, and in my list of security groups, I should have my Mailhog SG security group. The next step is to define our Mailhog task definition. And I'll refer to the documentation once more to preview the documentation for this resource. So we'll need to provide a JSON containing the container definitions and the network mode, which in our case will be AWS VPC. We'll be launching our container using Fargate, which abstracts the infrastructure management for us. We'll also need to define our memory and CPU and provide a unique name for our task definition in the family variable. For the container definition, we'll provide the same variables that we specified in the previous video for our task definition. I'll exclude the SMTP port mapping. We won't be testing the SMTP server in the video. We'll just preview the web client once it's deployed. I'll pass my environment variables in the environment array. This will be an array of objects, each object containing the name of my variable and its value. Let's go ahead and format our code and then validate it. So we have an issue. Let's add some commas in our JSON code and also replace the JSON decode with JSON encode. That should fix the error. I'll then go ahead and apply my changes, which will add the task definition. I can preview the task definition using the AWS toolkit. So it seems to be taking some time. Let me give it a moment to load. Lastly, we need to define our service. Our service will be running in the cluster that we defined above. So we need to reference the cluster ID and the task definition as well that we just defined. The desired number of containers will be 1, and our launch type will be Fargate. For the network configuration, we'll pass in the security group that we defined earlier. We'll also assign an IP address to the task when it launches. And lastly, we need to provide the subnets where the service will be running. This will be the subnets of our default VPC. To retrieve the subnet IDs, we'll specify another data source. Let's go ahead and validate the code. So the data source we used has been deprecated. Instead, we need to use the AWS subnets. Okay. Let's refer to the docs for that and see what I missed. So for the AWS subnets data source, I need to use a filter. I'll just go ahead and copy that and pass in the VPC ID in the values array. And validate it once more and then apply the changes. And our task is running. I can preview the Mailhog web client on this IP address on port 8025. If I refresh my AWS Explorer, here I should see the resources that have been deployed. Lastly, we can use Terraform destroy command to delete or remove the resources. And that's it for this tutorial. If you find it helpful, be sure to leave a like or a comment. Until next time, cheers.